Hi students, so welcome to Physics to Learn AR channel. So in last previous classes we have been discussed regarding the concept of gravitation. So in this class we are going to discuss regarding the concept of gravitational intensity and potential. So as if we know, if you have been taken Earth will be having some attractive force, that regions which you can call it as gravitational field or gravitational field intensity. So regarding this gravitational field intensity explaining, suppose we keep a point mass m0 in the gravitational field. So the mass m0 experiences a gravitational force, because already you have been studied that whenever you are having two bodies, between them it will be having some gravitational force. So that what's the formula for gravitational force? We have been proved already. F is equals to capital G into capital M m0 by r square. So now we can define the gravitational intensity as E is equals to F by m0. So by substituting the F value, we can get it as E is equals to capital G into capital M by r square. So with this we can tell the definition of gravitational intensity as, so which we can tell it as, so the gravitational field intensity at any point in a gravitational field is defined as, so which is nothing but we can see it as force acting on a unit mass placed at that point. So that which is nothing but, which you can define it as E is equals to, so F by m0, force acting on a unit mass placed at that point. So in simple form, which you can define it as E is equals to F by m0. It is also called the strength of a gravitational field. So the further concept, which we can take it as a gravitational potential. So if you have been taken a body which is at infinite distance m0, at infinite distance, in order to bring that to a distance of r which I have been taken, so then the gravitational potential, how we can define? So this is a standard definition, so which we can be used. The gravitational potential of a body at any point in a gravitational field is defined as the work done to bring a unit mass from infinity to that point without acceleration. So this is a basic definition, so which we can take. So initially object is m0 at infinity, we are bringing to a distance r. So for that, to move the mass from infinity to a distance r, we should have to do some work. So that work, which we can call it as a gravitational potential. So that V is equals to minus capital G into capital M by R, so which we can prove it. So now gravitational potential energy, in simple form, which you can call it as PE, potential energy. So this gravitational potential energy, in simple form, we can tell it as mass into gravitational potential. So just now we have been proved the value of gravitational potential. So V is nothing but minus capital G into capital M by R. So by substituting that value, so we can get it as, so the gravitational potential energy, which we are going to get it as minus G capital M into small m by R, so which we are going to get. So this gravitational potential energy, so which we can be done it as like this. So this gravitational potential energy can be varies depending upon the height. So gravitational potential energy at a height above the surface of the earth, so we can take it as, so R plus H. Why? So above which we have been taken. So if it is on the surface of the earth, so we can use it as potential energy. Our gravitational potential energy is equals to capital G into capital M into small m by r, where r represents a radius of earth. So in definition form, how we can tell this gravitational potential energy? So the work done, to displace a body from infinity to a point in the gravitational field, in the gravitational field against the gravitational field direction is called, which you can call it as gravitational potential energy. This gravitational potential energy in general, which we can denote it by the symbol U. So with this now, which we are going to discuss, which we are going to prove it as regarding this gravitational potential energy. So equation for gravitational potential energy. Before that, so which we can assume here as the diagram as like this. So this is the gravitational, so mass of the earth which I have been taken, and a body is initially at a distance a, which is at point A, which is at x. So it has been moved from A to B. That small distance I can take it as a dx. So if you have been brought that mass to point P, which is at a distance r, at this point I have to find out the gravitational potential energy. In order to prove this, which we are using one method which you can call it as integration. In last previous classes also we have been used in previous chapters. So consider a body of mass m placed at a distance x from the earth of mass m and radius r. So gravitational force of attraction, whenever we are having two bodies, so between them it will be having force of attraction. That force of attraction is nothing but so capital G into capital M into small m by x square. In order to move from A to B, we should have to do some work. That work done I can take it as dw, and distance I can take it as dx against the gravitational force. With that equation I can write it as dw is equals to f into dx. So by substituting that, dw is equals to capital G into capital M into small m by x square into dx. So taking this equation, integrating on both sides, so which we can get it as like this equation. So the total work done in bringing the body from infinity to the point P is given by, so W is equals to integration of infinity to R capital G into capital M into small m by x square into dx, where dx is a small displacement which you have been taken from A to B. So on integrating this, so which we can get it as, so x to the power of 2, if it moves upwards, we are going to get it as x to the power of minus 2. Capital G is a constant, capital M is a constant, and mass of the body is a constant. So which we can take out, and using integration of x to the power of minus 2 into dx value is nothing but minus 1 by x. So by substituting that, so which we can get it as, by applying upper limit and lower limit, so minus capital G into capital M into small m by 1 by x r to infinity. By substituting the upper limit and lower limit, so we can get it as work done W is equals to minus capital G into capital M into small m into 1 by r minus 1 by infinity. So we know very well 1 by infinity is nothing but 0. By substituting that, work done W is equals to, we are going to get it as minus capital G into capital M into small m by r, so which we are going to get. This work done can be stored as gravitational potential energy. So that's value which we can be used. So same manner, r value which we can take it as on the surface of the earth, r above the surface of the earth. So this is like application part. work done to lift the body from the height h1 to h2 is. So W1 is equals to surface above the surface of the earth means minus capital G into capital M into small m by r plus h1. In the same way, W2 is equals to minus G capital M into small m by r plus h2. So we need to find out the work done. Work done W is equals to W2 minus W1. On substituting this, the final equation, so which we can get it as like this. So W2 value and W1 value, if you have been substituted, which we are going to get it as like this. Hello students, please subscribe my channel, like it, and then share to your friends. So gravitational potential energy is given by the equation. So just now only you have been proved regarding the concept. C is equals to minus G capital G into capital M into small m by r. So that is the answer. So thank you for watching. Have a nice day.